So we talked about curiosity before. Do you think curiosity is a word that can be applied to AI?
It already is being applied to AI, actually, into several learning algorithms in the context of AI. And one of the ways that it's being applied is in the sense of exploratory information search. So sometimes AI systems can learn better when they seek information just to kind of like map out their environment more. In that sense, I think, yes, they can be curious. But there's this other sense that humans, when we talk about being curious, I think part of what we're reporting is some sort of internal feeling of wanting to know. Right?
It's a drive. It's a motivation to learn about the world. And I guess the question is, does AI have that same drive?
Yeah. I mean, you can program in a tendency to seek information in particular ways. But in the human case, we often call curiosity an epistemic emotion. And that's because it's an emotion that's related to the acquisition of knowledge or learning. But the critical word there is epistemic emotion, right? And I mean, right now, I think I feel safe saying AI doesn't experience emotions. I think that could change, right? I think technology could change, and that it could turn out that I was wrong. But my current bet is that AI does not feel emotions. And so if what we mean by curiosity is an epistemic emotion, then the answer is going to be no.
How would we know if AI has emotions?
That is a great question. I would want to think about how we make that inference for non-human animals, because we face a lot of the same challenges there.
So I know that when I kind of know how my dog is feeling most of the time. I can look at his face. I think he has an emotional response arranged very similar to humans in all kinds of ways, whether he's sort of upset or anxious or, moping. I can sort of guess that. I think, and I would bet I'm reasonably accurate on that.
Yeah, I mean, I think there's maybe two sources of information we use in a lot of those cases. So one is we observe something like input-output associations, right? So we observe that when he has I don't know your dog, when he has a ball, he's happy. When there's a squirrel, he's happy. When, doesn't have a ball, he's unhappy, and so on, right? So you observe all of these patterns of associations between things like features of the environment, your dog's emotional expressions, and so on, facial expressions, and so on. So that's one thing. We sort of observe these input-output associations. But the other thing is that we know something about the evolutionary history of dogs. We know something about the underlying mechanisms that might be generating those facial expressions.
Right, I mean, we know that they're kind of wired physiologically along similar lines as humans.
That's right. And so I think in the case of AI, we're going to be faced with those same two sources of information. We're going to have to evaluate them. So it's much more straightforward to think about how to evaluate the input-output associations, right? Somebody has a humanoid robot. We can do all sorts of things to see how various features of its environment affect its emotional expressions, what it says, and so on, right? That part's straightforward. I think the really tricky part is, okay, well, what do we know about the mechanisms by which it works? And are they relevantly similar to cases like what we know about the mechanisms in your dog or the mechanisms in humans that lead us to think that in those cases there really is such a thing as emotional experience?